Well, so it seems like the mistake was to keep carrying these two I had over here. So I didn't carry it there, but I brought it back here. So let me erase it. It shouldn't be here. It shouldn't be here either. And it shouldn't be here either, right? And I believe that's about it, right? Does that Yes. Oh, wait, over here, right? All right. So, I mean, just in case when you go back and watch the video, just get to see that I changed the mistake. All right, guys. What about higher order Cauchy Euler differential equation? So what we have done for this first part of the note was solve second order Cauchy Euler differential equation. Now, so let's see how do we solve a third order differential equation? Well, uh, although there could be a formula. Okay. Well, actually, let's do it the long way. So let's recall that we set y equals to x to the m, y prime. What about m x to the m minus 1? How about y double prime, m times m minus 1, x to the m minus 2, and then we would need a third derivative factor, m times m minus 1, m minus 2. Y to the m minus 3. All right. So what is this? So I mean, let's substitute everything where it corresponds. So the third derivative here, second derivative there, third derivative, first derivative here, and y just x to the m. Okay, so for one, this would be x cubed, third derivative, all this madness, m times m minus 1, m minus 2, y to the m minus 3. All right. Actually, guys, instead of writing this y to the m minus 3, how about we write it as x to the, as y to the negative 3 at once. I mean, I think it makes sense from here to there without having to write the whole process again because we're going to write a lot here. All right. So, what's next? Plus 2x squared m times m minus 1 x to the m times rather than m minus 2, x to the negative 2, using laws of exponents, all right? What's next? Plus x times m times x to the m minus 1. I'd rather write this as m x to the m times x to the negative 1. All right? And lastly, minus y, which is minus x to the m. So the reason why I went ahead and used laws of exponents to the x to the m minus the number, it's so I can eliminate the x's here. Okay, wait, this is supposed to be x right here, right? Not y, right? X, okay? Also, cancel, 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 and that's about it, right? Okay, so what do we have here? So x to the m, okay, m times m minus 1, m minus 2, x to the m plus 2m, m minus 1, x to the m plus mx to the m minus x to the m. Let that be equal to 0. And at this point, guys, it would be a good idea to factor x to the m. All right, guys. At this when we factor this x to the m, so let me highlight it so you can see how is this going to work. Okay. So at the same time, I'm going to expand this product of binomials. All right. So I'm going to do two things in one shot. Factor out x to the m, and then this will be m times whatever we get from foiling this, which is, here we go, m squared minus 2m minus m plus 2. And then I will also distribute to m and to the m minus 1. That'll be plus 2m squared minus 2m plus m minus 1. Let that be equal to 0. So the rest of the problem, well, actually, I would like to combine. I'm going to combine these two together. These are equal to negative 3m. Do you guys agree with that? So these guys right here add up to negative 3m. So I'm going to distribute. So x to the m, okay? I'm going to distribute m times m squared, is that m cubed? And m times negative 3m minus 3m squared, m times 2 plus 2m plus 2m squared minus, oh, actually, I can combine minus 2m plus m, is that minus m? And then minus 1. And let that be equal to 0. Do we have anything else to combine any further? It seems like it, right? So, uh, x to the m times m cubed. Okay, what about m squared? So negative 3m squared plus 2m squared, is that minus m squared? And then 2m minus m plus m, and then minus 1. And this is equal to 0. All right? So from here, actually, we're going to solve the auxiliary equation, the polynomial in m, not x to the m. All right? So let's set m cubed minus m squared plus m minus 1 equal to 0. And well, any ideas how to factor this polynomial? Rational root theorem, do you want to list all the zeros and test a few of them? Is there any other way, maybe? Factor by grouping, all right? So, I mean, rational root theorem may work, but sometimes we can see the pattern of numbers, and in this case, it seems like factor by grouping just works perfectly. M squared times m minus 1. And then there's nothing to factor in the second group other than an invisible 1 times m minus 1 equals to 0. And what do we have? M minus 1 times m squared plus 1. Let that be equal to 0. Okay? So from here, we get that m equals 1 or m squared plus 1 equals to 0. M squared equals to negative 1, and m equals plus or minus the square root of negative 1, which is the square root, negative 1, plus or minus I. Essentially 0 plus I, plus or minus I. All right? So we're gonna have three roots, one of which will be real. Well, I was gonna say distinct, but I mean there's only one real, and the other two is a pair of conjugate complex solutions. All right, so this means our solution will be of the form y equals to c1 x to the m sub 1. Let me call this m sub 1. All right, plus x to the alpha because of the complex solutions, x to the alpha, what is that? C2 cosine beta ln x. Okay, let me make more space here. Plus C3 sine beta ln x. All right. Okay, so what's M1? M1 is the real solution here to the equation y equals to C1, x to the first power. Well, I don't think we. Oh yeah, let me write it. X to the first power plus x to the alpha, which happens to be 0. So alpha equals 0. Beta equals to 1. Careful. Beta is not I. Beta is only whatever multiplies the imaginary unit, which is an invisible one here. All right. Okay. So x to the 0, C2 cosine beta, which is 1 times ln x plus C3 sine of 1 times ln x. Okay? So y equals to C1x plus x to the 0, which is 1, C2 cosine of ln x plus C3 sine ln x. Final answer. All right. So the question here is, remember when we first started this section, we took the time to derive the second degree polynomial in terms of a, b, and c. What did we get for that? We got this polynomial here, this auxiliary polynomial, right? Well, the question here is, can we create other polynomials for higher order Cauchy-Euler differential equations? Yes. All right. In fact, for the take-home quiz, you're going to show that the characteristic or auxiliary polynomial for a third order Cauchy-Euler differential equation looks like this: am cubed plus b minus 3a m squared plus 2a minus b plus c times m plus d equals 0, where you would just substitute the numbers and then solve the equation. Because, guys, doing all this takes a good minute to do, right? And what if I give you a fifth order Cauchy Euler differential equation? Well, actually, you could simply sit down and create other characteristic polynomials and simply have them as a in a matter of a formula sheet, And well, but yeah, you'll see that on the take home quiz. All right. Well, looks like this is the end of the section, right?